Hello, I'm Kang-myung Lee of Giontech. I introduce scale removing technology applying new kinds of chemical. And also, I recommend it to energy saving, quality improvement, and maximize revenue in industrial area. The scale is occurred in the most operating industrial facilities, so they need to remove the scale periodically. In case of current technology, the scale is not removed completely. That residual scale decrease efficiency of the facilities, even make replace them. However, scale sniper technology of G1Tech can remove the scale almost 100%. There is no decreasing efficiency and it doesn't need to replacement. These graphs show the content of the previous page. Current method show the efficiency is decreased after maintenance as like a figure 1. In other hand, scale sniper technology show the efficiency maintain almost 100% as like a figure 2. It means efficiency is maximized. Looking at the thermal conductivity of materials and scales, as shown in the table, various metals, which are materials of heat exchange equipment, have high thermal conductivity and the scale has very low thermal conductivity. When scale is formed on the metal surface, the scale acts as an insulator and interrupts heat transfer, which lowers the heat exchange efficiency of the facility. These photos are scale status and scale sniper application of the various facilities. Photos of the left sides are before applied, right sides are after applied. This table shows loss of energy of the electricity using heat exchanger in case of 20% efficiency reduction. This table is provided from heat exchanger manufacturer. Next, we'll talk about optimizing the facility by improving the inspection method after maintenance. Current inspection method is a visual borescope inspection after maintenance. In this case, inspecting all points of facility is so difficult. So checks are conducted mainly on checkpoints. Some maintenance companies exploit this and only maintenance checkpoints. Also, it is difficult to check residual scale amounts after maintenance. To solve these kind of problems, we recommend improved inspection method. It is after current inspection process as residual scale amount inspection processed through following equation. How to calculate residual scale amount is below. That is, current heat capacity divided by designed heat capacity and multiply 100%. Equation indicate 100% when there is no scale. Next is how to calculate energy saving after maintenance. You can calculate it easily with heat capacity formula Q equal mc delta T. In this formula, Q means heat capacity, m means flow rate, C means specific heat of fluid, delta T means temperature variation before and after maintenance. Here are 4 key checkpoints to check when choosing a maintenance method. First is high scale removal rate. Second is less physical and chemical damage to facility. Third is no environmental safety problem. And the last one is short maintenance period. The following diagrams and figures compare the pros and cons of physical versus chemical maintenance method. As shown in the diagram and figure, the physical method is less expensive to maintain, but has a lower descaling rate,
and the chemical method is more expensive to maintain, but can remove scale almost completely. When selecting a maintenance method, rather than simply comparing maintenance costs, it is necessary to review from an ROI perspective, such as an increase in CO2 emission due to a decrease in facility efficiency due to remaining scales, and a loss due to a decrease in productivity.
Because of above problem, the physical maintenance method as like drilling, pigging, high pressure washing is usually used in industrial site. However, these methods have some problem. They need a lot of time and manpower. Furthermore, they cannot remove the scale perfectly. Residual scale makes difficult to find local defect. For further explanation about scale removal, the scale occurred in the facility composed of hard scale and soft scale as like a scale description diagram. Hard scale means the scale hard as like a rock and even hard to scratch with a knife. Soft scale means the scale soft as like mud and sand. The pictures below are the scale diagram and actual photo after physical maintenance.
In case of precise high pressure washing at the right side, only the hard scale hit by water is removed, so the scale is remained as like a diagram. Then let's see how to do high pressure washing. As you can guess from the video, soft scale can be removed from the inside of the tube with high pressure water washing, but hard scale is difficult to remove. In the case of the shell side, it is possible to remove the scale on the part that comes into direct contact with water, but it is difficult to remove the scale on the inner part that does not contact with water. This chart compares the pros and cons of the scale sniper and the widely used acid-based chemicals in chemical maintenance methods. The use of acid-based chemicals was extremely limited as hydrogen embrittlement, local corrosion, and intergranular corrosion could occur, which could seriously damage the equipment. On the other hand, Geontech's scale sniper is a chemical that hardly causes material damage, so it can be safely applied to most facilities. In addition, Geontech's scale sniper provides a change report of material properties verified by the American standards, and this data is used as certification data in most countries. And now we compare the current chemical maintenance method and scale sniper method. First, acid-based chemical. Acid-based chemical has many problems. The biggest problem is hydrogen embrittlement. Hydrogen embrittlement means hydrogen atoms infiltrate metal atoms and weaken the metal significantly. It makes the trouble as like a right side of photograph. The next figure is about local corrosion, which is caused by concentration of corrosion on a part of the metal surface as shown in the photo on the right. When localized corrosion occurs, the strength of the metal in that area is greatly reduced, which can cause problems with the equipment. The next picture is about intergranular corrosion. As shown in the picture on the right, corrosion is concentrated in the area where grains meet. Intergranular corrosion can also significantly reduce the strength of the metal when it occurs, causing problems with equipment.
The next is removal mechanism of the scale sniper of Geontech. In case of soft scale, as like a above diagram, it removed by dissolution. In case of hard scale, as like a below diagram, it weakens as soft scale by chemical and removed. These pictures are the scale diagram and actual photo after using scale sniper. As like pictures, you can see the soft scale and hard scale removed perfectly. The next is expected effect when scale sniper is applied. First one, energy cost as like electricity, fuel is decreased 10 to 20%. Second one, maintenance time is reduced more than 75% compared with high pressure washing. Third one, maintenance manpower is reduced more than 75% compared with high pressure washing. The last, the most important one is improving productivity by facility optimization.
In addition, let's talk about the features of the scale sniper.
First, it is easy to control a job because of no exothermic reaction. Second, it is safe to facility because of almost no local corrosion and hydrogen embrittlement. Third, it is safe to workers because of little risk of injury from human contact. The next, let's talk about how to clean various facilities. The first is a shell and tube type heat exchanger. The cleaning jobs is as shown in the above photo. Before cleaning and after cleaning is as below. Next, let's watch the 3D cleaning video to help you understand the job. The second is plate type heat exchanger. Current maintenance method is disassembling, cleaning, and reassembling. In other hand, new method of G1Tech is just circulation cleaning. There is the table about difference between current method and the new method in the upper right corner. Next, let's watch the 3D cleaning video to help you understand the job. The third is AFC. There is an outlet temperature change of before and after cleaning in the upper left corner. There is a temperature change graph in the below, and there is the working photo and before and after cleaning photo in the upper right corner. In addition, there is the photo about AFC which corroded by alkali foam cleaner. Next, let's watch the actual cleaning video to help you understand the job. The fourth is fin tube type heat exchanger. From top to bottom, there are scale diagram, before and after cleaning photos, and hard scale dissolution test photos. Next, let's watch the 3D cleaning video to help you understand the job. is the tube bundle of oil heat exchanger. Current method is high pressure washing with 1 to 2.5 kilobar of water. It has the problem that only the outermost part of the bundle is cleaned and the inner part is hardly cleaned. In other hand, our method using chemical weaken the hard scale as soft scale and then wash it. This method can remove the scale in the inner part of tube bundle. Please watch the video to learn how. The last one is the pipeline. In case of pipeline, as like a diagram in upper side, you can clean as a simple circulation method with a pump, hose and other thing. Below is a photo of field job and how to do it is shown in the following 3D video. Scale sniper technology of G1 Tech is proven in various industrial fields. We will be your best assistance to your technological innovations so that you can save energy, improve product quality, and maximize profits by removing almost 100% scale. Thank you.